Okay, so there's some interesting things going on with our third problem here on this page. We have f of x equals the absolute value if x is not equal to 0, and 1 if x is equal to 0. Now, the Desmos calculator can't handle the not equal to, and so what we're going to do is we're going to break this up into two parts. Remember, not equal to means anything to the left of 0 or anything to the right of 0, but not 0. So we're going to break this up into x is less than 0 or x is greater than 0. So we're going to have two function values there. So when I come over to Desmos, oh, and the other thing I want to mention is when you're typing in the absolute value, the way we do that is ABS parentheses x, and that's how you type in absolute value. So I'm going to come over here and type ABS parentheses x, and then space my braces. I'm going to have x is less than 0, and then I'm just going to copy that and put that down here and do that again for x is greater than 0. So we have two spots. Now I'm going to make those both the same color because they're both part of the same graph. And then for the other part, I have f of x equals 1, and that's going to be a different color, but that only works for x is equal to 0. Okay, and again, remember that's grayed out, so I'm going to go ahead and use a dot for that, 0, 1 for that dot, and make that blue. Okay, and then for the value right here at 0, 0, it's undefined, right? So I need to make a open circle at 0, 0. So I'm going to make that black and open. Okay, so there is the picture that I have. Let's go back and graph that. So for the black function, I have an open circle at 0. And then at 0, for the blue, I have a 0, 1, a dot right there. So the domain, because it goes left forever and right forever, is going to be all reals. There's no values that it misses in the center. Even at 0, it is defined at 0. The range on the other hand, starts at 0. The lowest y value could be a 0, and then yes values, yes values, yes values, all the way up till infinity. We put a parenthesis on the 0 because at 0 it's an open circle. You're not allowed to be equal to the open circle. To find f of 3, I come over here, use another value, and just type if x is equal to 3, what would y be equal to? And in this case, y is equal to 3. So we have f of 3 equals 3. Next, I'm doing f of 0, so I'm just going to come back over here and change that to 0. And at f of 0, we know it's not equal to 0, 0, but it is equal to 0, 1 because that is the closed circle. So I come back over and f of 0 is equal to 1. Obviously, you can also plug those in to the functions if you would like. What are the values of x for which f of x is equal to 2? So I'm going to come back over here and I'm going to take out that one. I don't need that anymore. So f of x is equal to 2. And actually it pops up twice. One over here at -2 and one over here at +2. So what are the x values? Well, if x equals -2 or if x equals +2, you see that we have a y value of 2. Okay, so that's that problem. Next, we have an application problem for piecewise functions. So we have Lone Star Utility uses the rates below to compute the monthly cost of natural gas in terms of cubic 100 feet for its customers. So we have the charges per month. We have a $25 base charge, and then we have a rate for the first 100 CCF, which is cubic 100 feet of natural gas, and then after 100, you have a different set. So we have two different domains here. We have the domain from 0 to 100, And then we have another domain of anything greater than 100. Now, no matter which domain that the customer belongs in, they both are going to have the $25 flat fee. Everyone has to pay that. No matter if they have less than 100 CCF or more than 100, both categories need to pay the $25. If we are in the blue domain, 0 to 100, then you have 73 cents per CCF for the first 100. What that means is we're going to have 0.7325 for every x between 0 and 100, and because we do have because our x does lie within 0 to 100, then we just have 0.7325x for every x that you have. So you only want to pay for what you're using. And then you're going to be charged 63 cents per CCF for anything more. But we don't really have to worry about that whatsoever, because in this case, in my blue case, between 0 and 100, that doesn't actually exist at all. Let's go over to the greater than 100, the orange domain. So for the first 100 CCF, you're going to be charged 73.25 cents per CCF. Now, because we absolutely know for the orange category, they've already surpassed 100. So they're going to have to pay $100 times 0.7325 for that category. Plus, for anything additional, we're going to have to pay 0.6350 times any additional CCF over 100. Now, the way we do that, kind of like our cell phone example, is going to be x minus 100. I don't have to pay for the first 100 in this rate because I've already paid it in the 73 cents rate. So the first 100, I'm not paying for that in the third category because I've paid it in the second, but anything after that, I'm going to have to pay in that category. So when I write my piecewise function, we're going to let x obviously equal the number of CCF units of natural gas. Probably should have done that first. In the blue domain, for anything for between 0 and 100, we have the 25 plus 0.7325x. Okay, so that one's pretty straightforward. It's the orange category that's a little bit messy. So I'm going to take a little bit of work here to do that one. So we have $25 for the base charge, plus we have 100 times 0.7325, which turns out to be $73.25. Plus we have 0.6350 times x minus 100. So that's got to get distributed, 0.6350x, and 0.6350 times 100 is 63.5. Then we have 25 plus 73.25 plus this. So I have to add up. So I'm going to get out my calculator, and I have 25 plus 73.25, minus the 63.50, which gets me 34.75 once I add all of those constants up. Then I have the plus 0.6350x, and this is for if x is greater than 100. It's the second one that students sometimes have a concern with. So next we need to graph this function. So I get out my graphing calculator. I'm going to X out of all of the functions that we had for our last problem. And if you were not zoomed out, make sure you go back to your default zoom. So we're going to go ahead and type in our new functions. Okay, I got that typed in, but clearly I can't see anything right now. The other thing I want to do is make sure this one is blue, it is, and the second one was orange in my graph, so just to match with my other colors. So if I start scrolling out, I can start to see the graph here. And actually it doesn't look like I need to zoom all that much. Here we have a point at 0, 25, and it's not listed there as a closed circle, so I want to type 0, 25, so I can make sure that's listed as a closed circle. And the end point and the starting point of my intersection is the same, 100, 98.25, so I'm going to type that in as well. This is the 0, 25 is a closed circle for the blue. So 100, 98.25 is a closed circle for the blue. It's an open circle for the orange, but it doesn't really matter if you have an open circle and a closed circle on top of each other, it still means closed, right? So I'm going to hop back to my paper and draw this for you. So my blue function, we said, starts at 25 and increases, and it stops at 100, what was that, 98.25, I think. Then the orange is an open circle right there, and then it's a little bit flatter, okay? So that's what my graph looks like for this particular function. The next question we have is, what if a customer used 135 CCF of natural gas this month? How much will be due on the bill? Well, 135 is definitely an X value because remember, X is equal to the number of CCF of natural gas. So if X is equal to 135, I'm trying to figure out what Y is, or F of 135. So what I'm going to do is go back to my graph and do a new equation, X equals 135. That can be a totally new different color because I just need to know where that lies. 135 does lie in the orange domain because it's greater than 100, so we're going to be paying the blue rate for the first 100 and then the orange rate for anything after that. So here I have 135, 120.475. That's 5 makes that 7 turn into an 8 because I have to round to the nearest penny. So Y is equal to 120.475. So that gives me an answer of $120.48 for the bill for that month. For the first 100, they get charged one rate, plus anything over that, they get charged the orange rate.